Hello, guys. So we can start the session in 3 minutes. Some participants are joining, so we can wait. So hello, guys. We GDSE Government Engineering College Thrissur and Government Engineering College Wayanad collaboratively conduct the intro to machine learning. So machine learning is rapidly growing field that revolution the way we approach problem solving and the decision making. So today we have our prestigious speaker Nishant Roy to take the session. So let me invite Nishant to take the session for this amazing gathering. So, Nishant, are you there?
Hello, I'm audible.
Yeah, you're audible. Yeah.
Okay, so thanks for the introduction. So, going ahead with the PPT. Okay.
Are you sharing the screen?
Yes, yes.
But can't view.
Wait a second. Now,
Yeah. Now it's okay. Yeah.
okay. So, going ahead with the seminar. Uh, these are all the things which we are going to cover. These are the segmented part with the introduction of the machine learning. So, before starting, I have a question. Can anybody explain or give a brief anything that they can uh, know about machine learning? What is machine learning like? Anything, any vague idea, anything. Hello. Hello, am I audible?
Yeah, 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 you're audible. Yeah.
No one is answering. It
Like,
is not about like if you are going to answer, anyone will judge you. Here, all are here for learning, so there's no need to shy. Okay, you're giving chats. Wait a minute, I have to join with one more device. Read what are you saying. So you can chat now. Keep some reply in the chat box if you are not comfortable with speaking. Analyzing data. Okay, something like that. Great, great, great. Have to go back again. So, what is machine learning in general terms? If we have to describe to any 3-year-old child, it will be like machine. AI is a machine that tries to mimic, understand the data, and to mix understanding data and instruction with help of computer. Okay, great. That's too great. So, what is AI is general term, not a actual thing that exists in the world. It is just a general term named to describe any machine that can perform tasks like humans with a human level of intellect or knowledge. So, going ahead with that, there are three types of machine learning categories based on their level of intellect or level of intelligence that they possess right now. So currently we are in artificial narrow intelligence. So what the narrow term here describes is that that kind of machines which can perform a certain task with a certain accuracy. Now, as you have gone and known about the chat gpt and dolby etc, that current generation of ais, they are in they are in midway of something in between narrow intelligence and general intelligence. In general intelligence, what we describe is a machine that is capable of doing any task like human beings, like a human replica of intelligence, kind of like that. And what we explain by the super intelligence is what we see in the movies, like the Terminator or something like that, where the machine has surpassed the human level of intelligence. So if we're going ahead with that, you have seen these kind of images internet, like the big Venn diagrams in which the bigger circle describe the artificial intelligence, in which the machine learning is inside, and inside that there is deep learning. There's one more sub circle like DS, data science, that is a completely different topic that we're not going to describe right now or discuss right now. We are currently focused on the machine learning part. That is the actual implementation of AI. So moving ahead with that, anybody knows this bearded fellow or the old man? Hello, connection issue. You can chat if you are not comfortable with uh, mics or vocal communication. Simple one liners will also do. If you don't know, you can just say that no, don't know. It is also written at the right side. Okay, right. Great. So what he is, he's the first person to coin the term AI in a conference, that Dartmouth conference, that is in the Stanford University in USA. So what he coined is that the AI is a technique of getting machines to work and behave like humans. In a very vague and very simple way, he coined this term, the AI, artificial intelligence, in 1965, way ahead of us. Even we were not born that time. So moving ahead with them, what is machine learning now? It is a subset of AI that we know from the previous slide, and what it can do, it can implement the statistical models like the probability model, like difference, mean, median, mode. Like these are the simpler models. They are much more complex model. Implementing those model and trying to predict an outcome on the basis of data. There we doesn't need to program like if we are going to program a result management system or database management system like a code in which we will provide marks of five different subjects. And after providing the marks of five different subjects, we will calculate a sum, and then we will do the average, and then we will calculate the percentage part. It is a processed, means it is, we have to think of every and each and every very outcome. If we will provide 50% marks, what will be the result? Is it a plus? Is it a B plus? Like we have to think of every step in the programming. But in machine learning, it is like we will just provide the data and the expected outcome. It will just do the programming. It will create the program for us. Like you can also read this, but I am just going to give you the brief insight. Now there is one more step inside the onion of the AI, that is deep learning, a subset of machine learning, which is a mimicry of human brain, like how the human brain function. Like there is neuron, there are connection between the neuron. These neuron can further make some tissues like that. In this, these are all in biology. But what in computer science, what we are trying to do, we are creating a black box like a system in which there are certain nodes connected with edges, which with each edge has some weight attached to it, and each node has some input. So the input gets multiplied, or some kind of operation is done with each weight, and then there is pass on to the next node like a brain neuron system, and it tries to perform some complex task. Now going ahead with that, there are some basic differences between all three of them. These are like onion rings. Each one has a subset to one. Like DL is a subset of ML, and ML is a subset of AI. And each one of them were later gone in time. Like one was in 1950, one was in 1960, and then was 1970, the DL part. And every one of them has some drawbacks. And but the main part is AI is not a actual programming or any kind of implementation. It is just a coin term, like a theoretical part. And the machine learning and deep learning is the practical implementation of that AI. Now going ahead with that, these are some of the use cases which are currently used for the machine learning and AI in general. Like you can see for fraud detection, like in your Google Mail, there are some spam folder where the mail of some XYZ person are stored because of the characteristics similar, because of their mail characteristics similar to some of the fraud mails. So this is one example of fraud detection. There are some more like prediction and predict analysis, means we can do the prediction of some certain task. Like there is a survey of certain area where there are certain PGs of different rate. We can predict like what will be the point to certain area which has the likelihood of certain amount of price. These are some of the implementation. You can go and ahead and see some more. Now, why we are here talking about AI is because of the this data that we have gathered for the 2025, this next 2 to 3 years from today. You can see that there is a general increment of requirement for different category of AIs, like object detection and text quality, OCRs and NLP, etc. In different fields of industry. And also you can see the characteristic requirement of AI in different countries right now. This data might not be as much as accurate, but it can give you some insight, like there is a demand in this field. Now these are the trends, means there are R&D or research going on these all of the topics, which will be very useful for you to do some further research. And like you can take this screenshot for your reference, like robotic process automation. What this describes is for a task, like we have to fill a form for a student, which we like teachers have to make your id card. For that they have to collect your data from google form and then process it, then it they have to form fill it in the format, then they have to print it. This repetitive task can be automated using robotic process automation, in which there will be a program which will be fed with your data or data set, and it will do the automation of that part and create your id card without being any human intervention. There will be some, but not that much. Now with the healthcare part, like there can be prediction of certain diseases before it occurs using the machine learning part. And there are very more, like there's one prominent in the lower half, you can see ai powered chatbot. You can also relate that with the uh, chat gpt, that is very much prominent right now. If you have not tried it, go and try it anytime. Now for till now, anyone has any doubt, anything that is not clear right now? You can send some yes, no, partially no, partially yes. Anyone? Okay. Okay, then moving ahead with the second layer of onion shell machine learning. These are some of the topics which will be covered. Is my audio clear? There is any issue with my audio or my English? Yes, no. Okay, okay. Now going ahead with the machine learning part, what it is, like previously discussed, machine learning is an implementation of AI using some statistical model or any algorithm, and which takes the data and forms the program for us. Like you can see here, there is distinguish between the traditional programming which we are doing. Sir, is deep learning is also a sector like deep learning in which active research is occurring? Deep learning is not a sector, it is a kind of a label given to you, like class 11th, class 12th, like that. Uh, After class 10, there is class 11th, then there is class 12th. Like there is increment in the classes, like that there is increment in the complexity of AI. AI is a general term given to any machine that is trying to mimic human actions. Now, under AI, there are some subcategories, that is machine learning, and under there is machine learning there is subcategory deep learning. And deep learning specifically focused on the neurology of uh, neurology similar to human brains. I hope that's clear. It's not it's a research field, but it is not a sector like that. Sectors are the topics that need the implementation of certain process of programming. Clear? Yes, no? If you okay. So with the machine learning part, you can see that the traditional program that we used to do and what we are currently doing also, like we have to give the data and the sequential process of how the data will be flow through the program, or that we known as program, to get an output. Like there is a program for marks calculation or report card generation programs. Those all take the data and there is sequential process written by us, like how the data will flow, how the name will be placed, where the name will be placed, where the marks will be placed, like the process, and to get the output, that is our result. Now, in machine learning, what we will do, we will show him the data set, like the whole Excel of your college students' data, and along with a format of a uh, report card, like a template of a report card. And now we will tell the machine learning machine learning to create a program that will fill the data from the Excel and into the template to create reports of all the 60 or 70 students of your class. Now, going ahead with that, there are several steps of machine learning, like a step of building a house, kind of. So, if we go with the flow, first one is gathering the data. Similar to like we need some brick, sand, and cement to make the house. to construct a house, like that gathering of data. Now the second part, that is preparing the data. Like a raw cement bag can be used in the house. We have to mix it with sand and like stones to make a batter or mixture that can be used as a glue to fix different bricks all together with them to create a house, wall, or fall ceiling, anything. That is preparing the data. Now third is choosing a model. Choosing a model is similar to building a floor plan of your house, like how, where should be the kitchen, where should be the bathroom, something like that. Now training is the process of making the house using the labor or the contractor will let's create the first floor, second floor, like that. Now the evolution is that after a certain stage or after building the house, there will be a visit by uh, the person who is whom for whom we are building the house. He will come here and check all the parameters, like the is the house 10 by 10 feet, or the length is 10 by 10 feet, like the color is proper or not, the windows proper or not. That is the evaluation part. Now what we do after evolution, if there is some fix, like the tiles should be of certain color and we have put some other color, then we have to change it. Like the color of the interior is something different and we have to do something different, that is comes under the hyper parameter tuning. And after that we can just give the house to the owner, like the prediction part. It is similar to house building, not properly simple, but something you can relate to understand. uh, Now going ahead, this is somewhat elaborated explanation with a block diagram of the difference between traditional programming and machine learning. Traditional programming, as you know, is very simple. We have to provide a data set, and with a handcrafted program, like you have to think of every and each and every outcome that can occur due to certain data, and you have to program a whole program, or you have to code a whole program, and inside the computer it will execute the data and create some results. Now what happens in the machine learning is that there are two stages of machine learning. First one is learning phase, and second one is prediction phase. In the learning phase, what we do, we give them a sample data. Like if we have a batch, batch of 100 data sets or 100 students, we will take 80 students or 80% of the data set to for the learning phase, in which we will provide it to machine with a example of, like we know certain person have certain characteristics, like he has topped in previous class, so might be he will be also topping in this class. So that is the expected result, and with the data of that 80 students and expected result, we provided to computer and told or ask him to make a program out of it, like what should be what and how should it be placed, like that. And that model is again pass on to the computer with the remaining 20% of the data to test that is it accurate or how the result is forming. Like that, you can see in the flow chart. uh, First, the learning part, we are making the program without us thinking about any uh, use cases or any of the cases related to the data. And next part, we are just simply passing the remaining data to computer to generate the result, and we can now give the computer any xyz result, any xyz data, and it can produce the result of that using the model which we have developed. Now going ahead with the flowchart, that the house building part, it is elaborately explained here. Like we first have to define what we want to do. Like before doing any xyz work or anything, we have to first think in the mind what we have to do or what all things are required. Then after thinking the objective or defining the problem statement, we go in the, we go in the, not in the market, in the deep web or any provider of data, where we go and collect the data from, like I was in this healthcare startup. There we have to require images of blood cells. So what we do, we visited hospitals asking them for the data set of the patients, and like that we have to collect the data. It can be from hospitals, it can be present in some of the data uh, libraries like Kaggle, like California University, etc. Now what we do, in the data there are some problems, for example, the images which we have collected from the hospital, there are some images which are totally off balance, like there are some color correction required, some trimming required, some kind of manipulation is required. Similar is what we do in preparing data. We have to uh, uh, see all the data is in proper condition or not. Is there some null values? Is there some problem with the data? Now, after the data is prepared and all the things that required for making the cake or batter is required, all the things are properly collected. Then what we do, we select an algorithm. Like there are various kind of machine learning algorithm which we will see after this slide. We will select which will be properly suiting for this kind of application. Like for object detection or for image classification, we required some kind of neural networks. For text detection, we can use SVM and etc. So selection of algorithm is done here. Then after selecting the algorithm, what we do is we feed the data into it and try to train a model out of it. Try to develop a programming program from it. And after training the program, we test like there is a ratio, there is a rule in the machine learning, that is what we call 80-20 ratio, in which the 100 or full sample of data is not used for training or testing the model. It is divided into two halves of 80% and 20%. 80% is utilized for training the model or creating that program, and the 20% is used for testing it, like what is the accuracy, how efficient it is, how much time it is required for a new data to classify. And then after doing both testing and training, we make the model to be ready for use, like be usable for implementation. We can't just give the person a Python file that the client will use. You have to implement it in web application or in Android application, etc., to be used by the end user, by the any the like the patients or anyone, etc. Now, for the models, the machine learning is further distributed in three categories: supervised, unsupervised, and reinforcement. The supervised machine learning is again further distributed under various sub branches like regression, decision tree, random forest, and classification. These are some kind of mathematical algorithms used for deducing some kind of prediction from the data set. So these are way more complex to be discussed. So I will just list it out. And for unsupervised, like there is clustering, association, and hidden models for unsupervised. And reinforcement is that some uh, uh, general term. There is no such specific algos required for it. It is very simple for us to understand. Now there are two kind of data flows, like continuous and categorical. Continuous are like the like if you have a Cartesian plane xy, and if you plot the data point, you can just draw a graph for that, like a parabolic graph or any kind of linear graph, anything. These all kind of data are called as continuous data. And categorical data are like which can't be associated with each other, like an image of a dog or an image of a cat, very commonly used examples. Now, going ahead with the supervised machine learning, anyone any doubt till now? Any doubt? Yes, no, clear. Okay. Now moving ahead with the supervised machine learning, the sub part of machine learning. Uh, this is the brief differentiation between supervised, unsupervised, and machine learning part, reinforcement learning part. Here you can see you don't have to read all the paragraph, just see the below image. It is very much clear in the image what they do. Like in the first part, supervised machine learning, you can assume by the word supervised that there is some kind of trainer or there is some kind of supervisor in this model who is responsible for training the process or for training the program. In which in this there will be input data along with the supervisor who will label the data to its class. Like if there is a dog image, it will be labeled as dog. If there is a cat image, it will be labeled as cat. Then it will be passed on to the computer to do the magic and create a program, and that program will be used for predicting the output. Unlike the supervised machine learning, in unsupervised machine learning, there is no supervisor as such. You can reduce by the name. There's no such person who will be labeling the data. The data are classified or distinguished or uh, predicted on the basis of certain characteristics which the model deduce from it. Like if we pass a cat and dog image to an unsupervised machine learning, it will just predict that cat have generally uh, um, uh, ears protruding out, and dogs have flapped ears, like that. It will try to reduce some difference between cat and dog. Difference between classification and regression model. It will come in later half. Just wait. And also in reinforcement, what it does is it will take the input, and the model will train and give an output, and the output will be again checked by a not a supervisor, rather than an agent, who will say is it proper or improper or what, and then on the basis of that it will give a reward to the model. And then the model will gradually in using the feedback from the agent, it will develop its insight of it, inputs, and create the model. Now, moving ahead with this explanation or graphical representation of supervised machine learning, there is a set of raw input data in the left corner, which is passed on to the algorithm. And before passing on the algorithm, there is supervisor who will take the raw data and label or classify it as a training data. Along with he will also assign a desired output for that training data. These two data set will be passed on to the algorithm, any kind of algorithms for supervised machine learning, which will be then passed on to the processing part, which will just means in algorithm there is a model development part, and processing is using that model to distinguish this raw data into their specified data sets or specific class. Now, in supervised machine learning, it can be distinguished in two parts, two phases of that. First phase is training the model using the label data by the supervisor, and second phase is using the model to differentiate the input or the new test data into their respective groups. Now, the question that is, what is classification and what is regression? Classification is like sorting them into two different classes. Or like in your class, there are male and female. What the classification model will do, it will distinguish it between the male will be distinguishing the males and females will be distinguishing the females. Like if you will plot a graph into XY Cartesian, it will try to reduce a straight line or a line which will be dissecting the dataset into two equal halves based on their characteristics or relations between them. And what is regression? Regression is like there is a graph which is going on with all the data points. Now you have to decide what will be the next data point on the basis of the previous data points. Like there is a graph or a graph of weight versus the height of certain people in certain region. uh, what it does is it will take that plotting and deduce a graph out of it. And then if we give him like there's a person of 5 feet 5 inch, and what will the expected weight of that, that is done by the regression model. Hope so it is clear. Now moving ahead with that, there are some examples of utilization of classification and regression. Like the classification can be used for fraud detection, email spam, diagnosing of like the images that we did. And regression can be used for score prediction, like what will be the expected growth of a company, or you can be used for a risk of certain plans, like what will the if, like there is some government initiatives, what will be the expected risk associated to that. It can be used by it can be reduced by regression models. Now there's some difference between regression and supervised and unsupervised machine learning. Like the supervised, it can take input, it will take input as well as output data, and in unsupervised there will be no such output data. Supervised machine learning are further classified into two categories, that is classification and regression. And unsupervised machine learning is further classified into clustering and association. Supervised machine learning are mostly used for prediction and predictive models, like for predicting the certain output. And unsupervised machine learning will be used for pattern and structure discovery, what will be the pattern or gathering the insight from the data. Now going ahead with that, some of the advantages of supervised machine learning are like you can define or you have the proper information of the classification done by the machine learning, like this belongs to cat or this is a image of a cat or this is an image of a dog. There is no ambiguity in that. And also you require relatively low amount of data to train a model. There is no such requirement of higher 1,000 images of data set. You can just train it with using relatively low amount of data. The results are more or likely accurate and reliable, and there are much more advantage you can see in the slide. So moving ahead with that, some of the disadvantages of the supervised machine learning is it doesn't work on real-time data. It requires some time of buffer time to process and give an output. So you can't just use it in that share marketing graph prediction, because it is all that simultaneous, and the supervised machine learning will not be able to catch up with the data flow. And along with that, supervised machine learning has a higher chance of higher requirement of labor by the human for that, like you have to pair a input with the output value, or sorry, expected output value. So it takes time, and also the execution of these algorithms relatively are time consuming and have very much requirement of higher end computing parts. And now moving ahead with unsupervised machine learning, anyone any doubt so far? Okay, clear. Now moving ahead with unsupervised machine learning. This is a the diagrammatic representation of unsupervised machine learning. The only difference here that you can see is the absence of supervisor. There is no such supervisor. What this kind of model does is it will take the raw data and try to develop insights from that. Try to develop some kind of relation. Like here you can see the triangle have three sides. Here you can deduce something like the squares have four sides, or the circles have end sides, and circles are colored in green, and triangles are colored in purple, and squares are colored in orange, like that. You can just see from that and deduce some kind of similarities between the data set. Now using that data set or similarities from the data set, it can select an algorithm, or it can deduce a model from that insights. And that model can be used for further classifying them, not classifying or distinguishing them between different classes. Like in my college or in any colleges, there are some kind of distinguish between, I will not try to say, but it will like there is distinguishing between the people who watches certain kind of cartoons, or we can call it animes, and there are some distinguish between the BTS or some singer patch. Like what we as a human do, if we will interact with each one of them and try to find out what are in similarities with them, like what is similarity with a person and me, and try to have association with them, and like that we make our group or clusters, and these clusters can be can be distinguished from others using that same key similarities, like they watch cartoon or they watch movies or something like that. So moving ahead with that, unsupervised machine learning is also done in two steps relatively. The first step is deciding or gathering the insight from the data and creating a model. And the second step is, after creating the model, we try to distinguish the groups on basis of the those insight which it has gathered. And this kind of models are used for two specific problems, like for clustering, like trying to create association between certain entities, and for trying to detect anomaly or some abnormal behavior in the data set or any kind of environment. Now moving ahead with that, uh, there are two subcategories, and those two can be used for different types, like face recognition, image recognition, city planning, target marketing, etc. Now the advantages of unsupervised machine learning is that we just need to provide the data into it, and we just doesn't need to have some label or some kind of pre-processing to it. It can be done by the unsupervised machine learning. Also, it is relatively easy and uh, much more simpler for as compared to supervised machine learning. And the disadvantage of machine learning, unsupervised machine learning, is like we can determine the hidden patterns, but we can't know what it associated with. Like we can differentiate the groups based on their some similarity, but we can't know what was that similarity in this kind of unsupervised machine learning. And it is relatively less accurate than supervised machine learning, and also it requires much more larger amount of data to perform the similar kind of task. Now going ahead with that, any doubts till now? No doubts? You can type in the chat box if you have some problem or something that is not clear. Yes, no, maybe, may not be. Okay, now going ahead with the different final class of machine learning, that is reinforcement machine learning. Now, unlike the previous two predecessor, the reinforcement machine learning is like just like training a dog or a 3-year-old child. What it does is it takes an input and does some random kind of response, or does some random kind of action, and based on that action there is one more agent which will just deduce that action and give it a feedback, like is it right, is it wrong, or what was it. And then the model will note it or have a memory of that, which will be used in further classification, in further prediction or prediction, in which again similar kind of data is available to that model. It will reduce it to the assigned action or reaction of the agent. Very simple, very similar to training a dog. Now in the pictorial representation, you can see there is a cluster of raw input data. What it does is it will take it and do some kind of state or action on it, which will be passed on to agent. Now agent will take certain algorithm and deduce was that action or set of action, in that which one was best or which one was appropriate to the outcome or result which we need. Now that action or the result can be passed on to environment, or the uh, where the raw data set is there, and that kind of state will be rewarded, and any other state will be punished for that action or state. Based on that feedback loop and based on this process, the model which is trained will use the raw data and classify it or distinguish or separate it in different classes. Now moving ahead, like there is one example that I want to give it to you, done by some YouTuber. What he tried to do is he developed an unity model of a city, a straight line city with different in, landscapers or different buildings. And what he wants to do is he want to create an Spider-Man like a character who will swing between those building without a human implementation or human interaction. In that, the Spider-Man or the character has a characteristics of swinging and releasing the web from his arms on the basis of the impulse or input from the environment. Now, in what it does, it will at the first generation or the first some time, it will randomly swing the web and randomly do some task, and on based on that, the agent is some one more kind of machine or machine learning part, which will there are two machine learning parts used in that one. Uh, the agent, and one the person or the character that is doing the actions. Now what the character does, it will swing the web randomly for the first generation or first certain time of some period of time, and the agent will take that period of time and reduce the one of the most appropriate reaction and take that as the initial point for the second generation. then the second generation of character will do those kind of movement, and like that the generation will go on, and slowly using the feedback, the model and the character will slowly develop the proper action, what it has to be done, or what how it has to swing between the buildings, and using that he can, or the character can swing. This was one of the example of reinforcement learning. There are many more like the robot or something in the inventory can do. Now moving ahead with that, the advantage of reinforcement machine learning is that it tends to solve complex problems with relatively less amount of input, or relatively less problems, and it is preferable for higher data or higher level of uh, data flow for proper solution building. Also, the disadvantage with the reinforcement machine learning is that if it is unchecked for a longer period, it can overload the system due to the reinforcement and the compute heavy part. Also, it is relatively less accurate, and it can't be, or it will produce some problem in the relatively small simpler problems, or simpler model training. And also you require ton of knowledge in terms of compute power for this kind of reinforcement machine learning. These are some of the use case of in general of ML, like where all currently these are used: energy sector, fintech, travel and hospital, manufacturing, retail, and healthcare, etc. You can see here some of the example listed below. Now going ahead with that, now there is a question that arises in each one of us: how to choose the machine learning algorithm for certain task, and what all parameters to be decided on that. So first of all, we have to take the problem statement, or the problem which we are going to address, and after that we will see what do we want to do with the data, or what we want to do with data. Is it to classify it between different classes, or is it to find some insight from it, or is it to, like the character, we have to train it to do certain tasks. Now using that, we can refer to the algo cheats, or algo cheat sheet, in which there are certain algorithm written, or you can google it in the mm, internet. You can see different kinds of algos required for different kind of problems. Like in computer vision, you can go for OpenCV. In machine learning, you can go for Keras, etc. Now these are the initial choosing of machine learning algorithm. Now for the second part, we have to also require some additional information about that. Like in medical sector, there is a strict code of conduct of 98% of accuracy required for any kind of AI or machine learning implementation. Below that, it will be not be accepted by any doctor or any medical practitioner. Now also there are some time constraint part, like in Netflix or in Amazon. We can't just let the machine train itself for a longer period of time, as there is a requirement of customer engagement with them. If we have to run the model for a longer period of time, then the customer will not be that much engaged because of the latency of the program. And also we have to see what all the linearity or the pattern between the features of the model or features of the data set. Like there can be a data set of different kind of car, and we have to see which all are aligning. Like the number of wheels can be directly assigned to the cost. Like two wheelers are less cheaper as compared to four wheelers or trucks, etc. Like that we have to decide some kind of correlation or linearity between them. And also we have to decide how many parameters are required. Like if we have a data set of a car, different car models, the model name doesn't give some significance to the pricing of the car. What gives the significance is like what kind of engine is there, what kind of wheels are there, what kind of is it a petrol, is it a diesel, etc., like that. And we have to also list some of the features, like what all important, like the similar the number of parameters will be used further by the number of features. Now going ahead with that, these are currently some of the challenges with the machine learning part. Like first of all, the application is advantages, like it has wide application. uh, it can be used to detect identify different kinds of trends and patterns. It can be used for multi-dimensional and various kind of data. Like it can be used for identifying voice. It can be used for identifying images. It can be used for identifying video streams, etc. And it reduces the human intervention or human involvement in certain tasks. And it can be used for continuous process. Like we can. It is not like we have trained once and we can't do it again. We can repeatedly do the training part again and again for different kind of data sets. Now the disadvantages with that is there is some kind of error susceptibility. Like uh, if the data set has some kind of miscellaneous values or some kind of problematic values, it can hamper the model's accuracy. Also there is requirement of data for training the data models, but like while I was in my startup, there was a high lower availability of the models for the malaria or any kind of diseases. Like in India there is no such a database for these kinds of things, so we have to take the data and we have to manually scan the slides, and then we have to duplicate it, and we have to do some kind of image manipulation for gathering the data set. Now also the time and resources are high for these kinds of model training and etc. And interpretation of the result is somewhat difficult and not that much usable. Like the result generated by machine learning has to be done some pre-processing before giving it to a user or any end user. Now some of the applications, like you already know, some of these are much more simplified version and real world examples taken from the current society. Now for the demo part, is anyone has any doubt till now? Any doubt, any problem, anything is not clear right now, you can just chat while. Okay, now if anyone has uh, their laptop in front of them, you can just go to uh, this teachable machine URL. I will also send it to you. This is the URL. You can just browse it in the internet. What it does is to allow you to develop machine learning model without doing any kind of coding. It is just like click, 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 and model is done. So there are few kind of example. One is image recognition, one is audio recognition, and one is posture recognition. So for this, we will just go with the image recognition part, and we will use the standard model. Now what we have to do is there are two kind of classes or two data set that we have to provide. Right now I have currently collected some of the data set for this example, so I will just use it. I have collected 40 images of both and helicopter and a tank. I will just give it a label. Now for training part. These are like epochs are the number of, like you can see here, epochs means the number of data samples that can be used for data set at a given time or given instance. You can play with it and change the size. And batch are the number of iteration or number of time it will train it, like the reinforcement learning part. Now learning rate is how many tricks it will do or small differences it will do in each generation or each batch. After each batch, we will just set it in the default and just try hit the training button. Now what it will do, it will take the 40 images of a helicopter tank, it will do the training part and develop a model. Now I think it has done the model training part and it is taking my image. Now if I will search for tank, currently it is trying to differentiate me it with tank and helicopter, which is not possible obviously. So now I will just provide it an image of tank, and you can see it has a 91% confidence that it is a tank. It might slightly vary because I can't hold the photo very stationary, as you can see. And also for now, if I go helicopter, as you can see, it is distinguishing the helicopter with 100%. Like it is 100% confident it is a helicopter. Like that, you can do some tweaking with that and change the data set. You can also increase, decrease. You can add more classes to it for prediction of data set, etc. You can just tweak with and play with it. So any doubts, any problem right now with? So also you can ping me in my social media accounts by scanning this QR. And if you have any kind of doubt, anything related to machine learning that you have some problem with, or any kind of programming problem, you can just ping me out. So any doubt, any problem? Hello. No problem, nothing, any doubts, anything, right? Like, is it is not important to be related to machine learning right now. Also, if you want, there are some, this is one of the course, open source society university. Like it is a open source BTech degree for us. Like it doesn't require to be enrolled. Like it will not provide you a certification of BTech degree. What it does, it will provide you a path or a flow of work, how you have to do to be a self-taught computer science engineer. There are some of the sections right now you can see. Like if you are totally new to computer science, you can go with the introduction of the programming, introduction to computer science. Now then you can jump to the core concept of core programming, like what all programming concept you have to know, like OOPS and etc. What all mathematical tools you required, etc. You can just go with this, and this is a whole timeline or a chart of different courses, different free courses that you can attend to increase. Like this is a course of Coursera, I guess. No, not for Coursera. Like this is a course of MIT where you can enroll and start learning the basic of programming, etc. like that you can go in lower section, and there are some courses in machine learning as well. So you can just go here, and these are some of the free courses by the top, like Andrew Ng. He is the first of the programmers of the developers who developed open source or object detection part. You can just enroll in this course also, and you know how to take the uh, course, etc. You can have just few hours of coding with him, and it will be very nice to know. If you want, I will provide it the link. Any doubt, anything? Be frank right now. I'm not going to bite you. No one is replying.